Today's episode is brought to you by Surfshark VPN. Stay tuned to find out how you can get a special deal for my viewers.
Hello and welcome to my channel. Rhino here. Today, I'm looking at the middle section of a sermon series from the NW Creation Network called Geology and the Biblical Flood. I'm skipping to part 2 because part 1 is called The Bias Against Catastrophism, which, in my opinion, is a rather boring topic. It's a half-hour video that will undoubtedly amount to not much more than geologists refuse to acknowledge the fact that catastrophes can have a geologic impact, while bringing up a bunch of catastrophes that geologists acknowledge had a geologic impact, like, say, the asteroid impact from 65 million years ago, or volcanic eruptions. Geologists don't ignore catastrophes. They just don't think that the only things that can have geologic impact are catastrophic in nature. I dealt with the catastrophism versus uniformitarianism thing in more detail in my series responding to Ian Juby's Complete Creation videos, though worth mentioning here is that when I made that series, I had not yet learned that Charles Lyell actually believed in a literal Noah's flood. He just believed that it was gentle enough to have not left any geologic evidence behind for us to find, using the existence of an olive tree that was able to survive the flood as evidence for that point. Because, man, does Juby spend a lot of time asserting that Lyell invented uniformitarianism as an excuse to not believe in the Bible.
Lyell convinced countless numbers of people around the world that this book was fiction, when in fact it was his science that was fiction.
Anyway, I will be skipping a lot of this one as it is a fairly lengthy sermon, so let's just get right to it. But first, a word from our sponsor, Surfshark. In today's world, online safety is an increasingly complicated aspect of our lives with a myriad of tools and services to choose from. One of the most important tools in your arsenal is a virtual private network, or VPN, and I am happy to continue to recommend Surfshark VPN to all of my listeners. I use it myself and am extraordinarily satisfied. Surfshark is a VPN that keeps your online identity safe by encrypting the information sent between your devices and the internet, adding an extra layer of security that can help keep your personal data protected from bad actors and data harvesting companies. It does this by creating a secure connection between your computer and their server, so that not even your internet service provider can see your online activity. I personally never use public Wi-Fi without using Surfshark. Surfshark swaps your IP address for a new one that is located at their servers, meaning that in addition to the added privacy, you can access streaming websites like Hulu, Netflix, or Prime from any of over 100 countries, giving you the ability to stream movies or TV shows that might not be available in your area. With no extra fees, you can install it on an unlimited number of devices, and it works with phones, tablets, PCs, and even on compatible routers using their easy-to-follow guide. That will protect your whole home in one fell swoop. For a limited time, listeners can get Surfshark VPN at surfshark.deal/Rhino and enter promo code Rhino to get 3 extra months for free. Surfshark offers a 30-day money-back guarantee, so there is no risk to try it out. Again, that's surfshark.deal/RHINO and enter the promo code Rhino for 3 extra months for free. And remember, by signing up for Surfshark VPN, you're helping to support my channel. Thank you.
The age of the Earth, also known as geologic time, stands as one of the main conflicts that exist today between biblical teachings and those of natural science.
Maybe this is a touch on the nitpicky side, but the age of the Earth is not also known as geologic time. The age of the Earth is just the age of the Earth. Now, the geologic timescale is a record of time that is based on the rock record of the Earth, and certainly there is a rock record on the Earth from very soon after it was formed, so we can calculate a minimum age of the Earth using the geologic timescale, but those two concepts are far from synonymous. And the reason I'm nitpicking here is to show that creationists aren't just sloppy when it comes to attention to detail, but they seem to have a disdain for attention to detail. It's a theme I've noticed over the years where they don't fuss over much about getting the minor technical stuff correct, even when it's simple shit like this that wouldn't ultimately hurt their point if they got it right. Which speaks to the fact that they aren't interested in their audience actually learning true facts, which then calls into question whether the sloppiness carries over into the more important details. And I think we all actually know the answer to that question.
But it should come as no surprise, given the anti-catastrophic bias of geologists, that all geologic features formed during the global flood would be misinterpreted. We should expect them to be misinterpreting geologic features today.
If you have a model for how something works, and one of the predictions of your model is that an unbiased examination of the evidence will lead you to the conclusion that your model is wrong, then your model might just be wrong.
Where does the concept of geologic time come from?
Why, I do believe that would be from the study of geology.
Well, geologic time is based on an interpretation of the rocks that were called sedimentary rocks.
Not really, no. I mean, that's certainly a part of it, but it is by no means the only part of it. Radiometric dating probably plays a bigger role in the determination of more precise dates than a study of sedimentary rocks would.
And there are three main types of sedimentary rocks. There are sandstones, made up of sand particles, when those are deposited. Shale is made up of tiny particles of silt and clay. And then you have limestone, which is a sedimentary rock hardened by calcium carbonate from the shells of marine invertebrates.
Incorrect. The three main types of sedimentary rocks are clastic, organic, and chemical. Clastic rocks are rocks that are made up of pieces of other rocks that have been eroded. Organic rocks are formed from biological materials like plants, shells, or bones that are compressed into rock. Chemical sedimentary rocks are ones that are formed through chemical precipitation. That is, a chemical compound is dissolved in water, and when the water evaporates, it leaves the compound behind. The types of rocks that you listed would all be examples of one of the three types of sedimentary rocks, but they are not themselves the three types. Also, you didn't get all three types in your examples. Sandstone and shale are both clastic, and limestone can be either biological or chemical, but the example that you gave is biological, so you completely missed chemical sedimentary rocks like salt. And worth mentioning is that these are the three general categories. This is by no means an exhaustive list of all the types of sedimentary rocks. There's also biochemical, volcanic tuffs, volcanic breccias, and a few more. But those three categories do encompass most of the sedimentary rock that is out there.
Now, generally, geologists view the various layers as forming in different depositional environments.
Well, not necessarily. There can be layers right on top of each other that formed in the same environment, but there has to be some sort of change that would produce a layer, because if conditions were identical, it would just be one big layer rather than a bunch of little ones. After all, that is how we define the strata, by their composition and lithology. And the most straightforward way for the composition or lithology to change over time is for the depositional environment to change. Though strata usually do have smaller layers within them called laminations, which are layers whose variation is more subtle than the variations between strata, different enough to be distinct from their immediate neighbors, but similar enough to be considered part of the same geologic event. I mean, if you really want to get into the nitty-gritty, technically speaking, the difference between laminations and strata is fairly arbitrary, usually centering around thickness. If it's less than 1 centimeter thick, it's a lamination. If it's more, it's a stratum. But typically speaking, a stratum will represent one depositional environment, and the laminations will represent minor variations within that environment. Cycles of evaporation, for instance.
And thus it is argued that these layers are separated by vast eons of time.
Well, it's not so much that they represent different environments, therefore they are separated by vast eons of time. It's more that we can see the rate of deposition that these environments produce today, and then use modern measurements to extrapolate how long it would have taken for a particular environment to deposit enough sediment to make a layer of a given thickness. Also, in a part that I just skipped, he marveled at just how much organic limestone there is in the world. That is, limestone that is made of the remains of living organisms. Young Earth creationism would have us believe that all of the organisms that make up the limestone lived at the same time when Noah's flood hit. The problem is, there's just so much of the stuff that it's actually physically impossible for that to be the case. I'm having a hard time finding exact numbers on this, but from watching a video of a guy making a bunch of lime out of snail shells, he used about 75 snails and got a brick that was about 10 centimeters by 10 centimeters by 10 centimeters. Probably a little bit smaller than that. I am guesstimating here, but I went bigger rather than smaller because fewer snails making a bigger brick would work in the creationist favor for this calculation, not mine. So let's even just round the number of snails he used down to 50. So it takes about 50 snails to make a 10 by 10 by 10 centimeter limestone brick, meaning that it would take about 50,000 snails to make a cubic meter of limestone. The total volume of the Earth is about 1 trillion cubic kilometers. The crust is about 1% of that, so about 10 billion cubic kilometers. Sedimentary rock is estimated to make up about 8% of all the rock of the crust, so that's 800 million cubic kilometers of sedimentary rock. Limestone is estimated to make up about 20 to 25% of all sedimentary rock, so going on the lower end there, that gives us 160 million cubic kilometers of limestone, or 160 quadrillion cubic meters. That's 1.6 times 10 to the 17th for those who use different names when the numbers get this big. At 50,000 snails per cubic meter, that would require 8 sextillion snails, or 8 times 10 to the 21st. A small garden snail weighs about 7 grams, and this is a generously low number as the brickmaking guy was specifically collecting large shells from snails that lived in the Amazon rainforest, not tiny garden snail shells. But at this generously low weight, we wind up with 56 quintillion kilograms, or 56 times 10 to the 18th, of snail that is required to make all of the limestone of the Earth. By body weight, this would be about the same as if 903 quadrillion people, or 9.03 times 10 to the 17th, lived all at the same time. To make these numbers easier to visualize, let's compare it to something that most of us are at least passingly familiar with: the Empire State Building. If the Empire State Building were completely hollow and you filled it 100% full of people, it would take more than 57 billion Empire State Buildings to hold that many people. With a footprint of about 0.2 square kilometers, that works out to 11.96 billion square kilometers. That's 23 Earth-sized planets with their surface entirely taken up with nothing but Empire State Buildings full of people. And remember, this is a fairly low estimate of the body mass of organisms with hard shells that would have to have existed at the same time in order for all the limestone of the Earth to have been formed in one single flooding event. This is, of course, just a back-of-the-envelope style calculation, so it won't be exact, and I mean, I didn't even account for the difference between organic limestone and chemical limestone, so let's just be generous and cut the number in half and say that it would only take 11.5 Earth-sized planets full of Empire State Buildings squished full of people, or snails, I guess, in order to make that amount of limestone. My point in going through this is just to drive home how impossible it would be for all of the organisms that made up the organic limestone to have existed simultaneously. There literally would not have been physical space for anything else on the planet if they all existed at the same time.
And is referred to today as the fossil record because it is believed to contain a recording of history, much like tree rings record the history of a tree's life, or ice cores record the history of the formation of that ice.
Dude keeps bringing up stuff that completely disproves creationism. Yes, tree rings record the history of that particular tree, and through the study of tree rings, we have an unbroken dendrochronological record that goes back at least 11,000 years. And with ice cores, it gets even worse for creationists. The ice layers can be dated by many different methods, but just from counting annual ice layers, they can be dated with visual stratigraphy as far back as 50,000 years. Well, that's as far back as they go reliably, but there have been some that have been dated this way back to 800,000 years. But then, once you add the other dating methods into the mix, the oldest ice core has been dated to 2.7 million years old. I'll just leave a card to a video where I went more in-depth in the topic of ice core dating than I'm going to do here, so go ahead and check that out if you want more information.
They argue that these various layers of sedimentary rocks that contain fossils record snapshots of time. That you had different plants and animals living during this time than you had during the time above it, and different plants and animals living in a different time above that.
Well, I mean, that's literally what we see when we examine the fossil record, so that does make sense. The fossil record is also an excellent way to track evolution over time, with the oldest layers having the most simple and least diverse organisms, with diversity and complexity increasing as time goes on.
Well, as I look at in other presentations, that's not enough to show evolution.
It is, but that's irrelevant. You could take away the entire fossil record, and it remains a fact that we have observed evolution directly, both in lab experiments and in the wild. And even without those direct observations, there's enough other data from a myriad of different sciences that demonstrates evolution to be a fact of life that a belief in young Earth creationism would still be untenable.
That there's different plants and animals in this layer than the one above it doesn't show that they've evolved. They must be able to trace the evolution of an organism through these various layers for that to really be showing evolution.
And that's been done. We have a number of excellent evolutionary series in the fossil record. The evolution of cetaceans, horses, apes, birds, and more are all very well documented in the fossil record.
They assembled the fossil record together by looking at exposed layers of rocks in different locations and finding commonalities. Finding the same layer that's present here is also present over here. So, for example, the Kaibab limestone can be found close to the top of the Grand Canyon. So the Grand Canyon but you'll see how the Kaibab limestone can be found close to the top of the Grand Canyon, but it's on the bottom of Zion National Park. You can see how I've linked those layers up to you for you. The Navajo sandstone and other formations can be found at both the Zion National Park and Canyonlands National Park, which is to its right.
Yeah, okay. We get the picture. I assume everyone's okay if we skip the rest of his explanation on how different strata are matched up in different locations. Like, this is such basic geology that I'm not aware of any creationists who deny it. In fact, I am aware that creationists like to overstate this point. Andrew Snelling, for instance, likes to claim that a sandstone formation in Israel directly correlates with the Tapete sandstone in the Grand Canyon in an attempt to demonstrate that some layers are global, which would be caused by a global flood, obviously. And while there are certainly layers that do match up over vast distances, that's not one of them. But to quote Snelling, he says, "There is no question that they correlate as direct equivalents, both in their stratigraphic position and in their makeup." Setting aside the fact that he just asserts that and gives zero data to support that position, while ignoring things like the fact that the Tapete sandstone is fossil-rich, while not a single fossil has ever been found in this formation in Israel, meaning that even if grain size and composition are similar, it's not a direct equivalent in makeup, as part of the makeup of the Tapete sandstone is all the fossils. But yeah, setting all of that aside, this quote makes it rather obvious that creationist geologists have no problem with the idea that the geologic strata can be aligned in this way. So I'm left wondering why you seem to be suggesting that such methods are unreliable. And I'll leave another card to a video where I go more in depth on the Tapete sandstone versus the Israel sandstone thing, because why not?
But fossils are frequently found out of place. You should not really assume that this fossil record, as they show us, is actually set in stone, because like I say, many of these fossils are found out of place, often by millions of years.
I'm gonna need you to provide an example for that claim, buddy. I am unaware of any fossil that has been found out of place. Occasionally, we do find fossils in younger layers than they might be expected in, but in those situations, the appropriate course of action is to adjust the range of time in which that organism is known to have lived. There's nothing about evolution or geology that insists that an organism must go extinct after a certain period of time, so there's not a problem with that. What would be a problem, though, would be the finding of a fossil of a type of organism that is known to have developed later than the layer in which it is found. The Precambrian bunny here being the quintessential example. Mammals didn't evolve until the Triassic, some 2 to 250 million years ago, so to find a fossil of a clearly modern mammal in a rock layer from a time period before vertebrates had even evolved would definitely throw a wrench into the works of both evolution and geology. But alas, no such discovery has ever been made. The best creationists can do is point to things like the coelacanth and say, see, evolutionists thought that this thing went extinct, but it's not. And then pretend like evolution requires things to go extinct after a certain amount of time, as if the so-called evolutionists aren't the very same people telling us that sharks first evolved 450 million years ago, and yet have no problem with the fact that sharks still exist today.
Well, we know that strata, these layers of rocks, do not take millions of years to form. We know this experimentally. We can easily reproduce this in a laboratory.
It depends entirely on the type of layer. The quickest types of rock layer to form can happen incredibly quickly. A volcano erupts, the lava cools, boom! New layer of igneous rocks that are solidified, if not fully cooled, within months. Now, for sedimentary rocks, the story's a bit different and will be different for each type of rock. The whole process of forming a sedimentary rock involves the erosion of grains from other already formed rocks, the transportation and deposition of those grains, and then their lithification into solid rock. Each step of this process can, in some circumstances, take millions or even hundreds of millions of years, but it can also happen fairly quickly in other circumstances. Sandstone, for instance, can become fully lithified in a matter of thousands of years in some areas. Notably, it's the weight of accumulated sediment on top of a previously deposited layer that will cause it to lithify. The weight will squeeze out the gases that are trapped between the rocks, and then the water that seeps in will bring minerals that crystallize and cement the sedimentary grains together. Now, if all of the rock layers that we see were caused by the same event, and that event were a global flood, then what we would expect to see is that all of the rock layers all over the Earth are the same kind of layer, a loosely sorted conglomerate layer with the larger grains generally at the bottom and the smaller grains generally at the top. Because if a layer was not fully lithified and it was disturbed by a flood, its grains would be swept back up into the flood, and the first grains to settle would be the larger, heavier ones. But the transition to the smaller grained layers would not be in stark layer lines. It would be a fairly gradual transition and would be roughly the same everywhere on the Earth. Since that is not what we see, in fact the various rock layers don't seem to be at all sorted by grain size in any way, shape, or form, we can be certain that all of the rock layers did not, in fact, form in one worldwide flood.
Experimentally, we know that particles don't fall at the same rate. If you take a graduated cylinder like the one in the glass cylinder and put a bunch of dirt in the thing, bunch of sand, and shake it up, it will automatically form different layers.
Dude really doesn't seem to know how to not debunk his own arguments. He's literally got a graphic up now that says exactly what I just said, including a test tube where such an experiment has been performed, in which you can see that the layers are formed in gradients, not wholly distinct layers. Even in the couple spots where the layers look distinct, you can still see without looking too closely that there are grains from the layer above it mixed in with its own grains.
We can point out some geologic features around the world that point to this as well. This canyon near Walla Walla is actually exposed Missoula flood deposit. So remember, the Missoula flood only lasted a couple of days as these waters plowed across eastern Washington. Well, the canyon wall that you see on the left there is a wall of rhythmite deposits that were formed during the Missoula flood.
Okay, so we're just going to go for blatant dishonesty then? The Missoula flood is actually more properly known as the Missoula floods. Did you notice the difference there? It's very subtle, but that missing S at the end of your presentation is quite telling. The Missoula floods were a series of floods that took place over the course of about 1,000 years, sometime between 15 and 18,000 years ago. Now, notice the term rhythmite for the type of rock that formed there. Given that rhythm is right there in the name, it stands to reason that these layers are understood to be the result of a periodically repeating series of events. And indeed, when looking into it, that's exactly what they are. Each layer represents a distinct flooding event that happened when Lake Missoula filled and emptied catastrophically. And would you care to take a guess what you find in these layers? Each individual layer is itself a gradient, with the coarse grains near the bottom and the finer grains near the top. The whole thing taken together is not a gradient. It's got dozens of layers that are each individually graded in such a fashion. On top of that, the tops of the rhythmite are usually marked by paleosols, that is, soil horizons that indicate a dry period where the top of the layer was exposed to air and accumulated topsoil. So there is evidence of multiple floods, all of which left behind the exact gradient that Noah's flood should have left behind but didn't, and separated by periods of dryness with surface soil accumulation on top of it before getting flooded out again. Now, it was at this point in my video making process that I began to have some suspicions about this guy, because I only recall responding to one creationist in the past who managed to debunk their own arguments this badly before. So, lo and behold, I found that this is indeed the same guy that I responded to back in 2020, who I dubbed the self-debunking creationists. So, it seems that his arguments have not gotten better over time.
Well, in 1669, Nicholas Steno, shown here, outlined the principles of stratigraphy, or strata formation, which are now commonly known as the laws of stratigraphy. These include the principle of lateral continuity. It is believed that strata originally extended in all directions until it thinned out at the continental shelf in the ocean, or was terminated by some geographic barrier like a mountain range.
To simplify that one, any particular stratum, if you trace it horizontally, is the same stratum the whole way through from the same time period, with the exception of the presence of features that interrupt the stratum. This is basically the one that allows us to correlate strata from different locations, like he complained about earlier.
The sediments that fossils are found in are laterally continuous or horizontally indefinite. They basically extend forever in all directions.
As with a lot of scientific laws, it is fairly idealized. Nobody believes that one single depositional environment extended forever in all directions. Anyone who has ever taken a high school physics class will be familiar with this sort of thing. There's so many problems on tests that stipulate that you have to ignore friction from air resistance or something similar when performing your calculations. Because laws of physics are simplified. The real world is so complicated that the situation in which one law of physics would be applicable exactly as stated pretty much never exists. Like, the more mathematical laws will often be packed to the brim with caveats explaining the precise scenario in which the law is applicable, and usually it describes a scenario that is rarely, if ever, found out in the wild. But often, the law will be useful in performing calculations in scenarios that are close enough. Boyle's law, for instance, is that the absolute pressure exerted by a given mass of an ideal gas is inversely proportional to the volume it occupies if the temperature and amount of gas remain unchanged within a closed system. Creationists will often use Boyle's law to show that our model of stellar formation is impossible, because the increasing temperature of the gas cloud would cause the pressure of the gases to increase to a point where they would just fly apart instead of being compressed together. But notably, gas clouds in outer space are not closed systems, and Boyle's law does not say anything about gravity. So even though the behavior of gases that Boyle's law describes is definitely a part of stellar formation, a straight-up application of the mathematical law is unrealistic in that scenario. Well, same goes here with Steno's fourth principle. Assuming equal deposition in all directions, a layer will continue unless it is interrupted by some other geological feature. The fact that we know that deposition was not and never has been equal in all directions is not a problem for this. It's simply a principle that helps us correlate the layers in different locations.
Well, this is not what we see today. We do not find sediments forming in laterally continuous beds blanketing the continent. They're formed in really small, little isolated sedimentary beds, like where a river empties into a bay or into a lake. It will deposit its sediments right there in a fan-shaped the river delta.
Okay, so you didn't understand it. That's okay. Or rather, that would be okay if you weren't speaking authoritatively on the matter as though you do understand it. Nowhere in the principle did it say that the depositional environment would remain a constant, but the fact is that we can trace some layers through multiple different depositional environments, and they are a lot of the ones that we still see today. Deep marine to continental shelf to shallow marine to beach to lagoon to coastal plain, and so on. The principle is merely pointing out that all of the depositional environments that are working together at the same time will be in the same stratum as each other, and you would see the transition between those environments if you trace the stratum laterally, unless there was an environment where there was no deposition in between the environments, or unless there is a more recent geological feature that destroyed part of the sequence.
This law and these observations stand as overwhelming proof of the biblical flood to all those blinded by their worldview, because only such an event is capable of laying down such broad-reaching beds of flood sediments.
If they were all flood sediments, then you might be partially correct, or at least less incorrect. But unfortunately for you, the strata that you're talking about contain a myriad of depositional environments that are not flood-based. You brought up river deltas earlier. That is one of the depositional environments that we can see in many places throughout the strata, all over the world. There are also alluvial fans, where rivers empty into dry basins, glacial deposits, where a glacier pushes sediment around as it moves, evaporative deposits, where a body of water has so little drainage that it evaporates faster than it empties, causing minerals to crystallize, and a whole host of other environments. Flooding is only one depositional environment. Like, honestly, pick a layer of sedimentary rock at random anywhere on the Earth, and you are far more likely to have picked a rock that was deposited in anything but a flood than to have picked one that was deposited in a flood.
Charles Lyell's thought that the present is key to the past. Well, we don't find sediments forming like that today. We don't find sediments forming in sedimentary beds that are hundreds of feet across.
Don't we, though? A beach is a type of depositional environment. The longest beach in the world is the Praia do Cassino Beach, which, depending on how it's measured, could be anywhere from 212 to 254 kilometers long. A fact that is confusing at first, but makes sense in light of the coastline paradox, which just describes the counterintuitive fact that coastlines are not well defined, and the more precisely you measure them, the longer your measurement will end up being. Anyway, that's a depositional environment that is over 200 kilometers long. And it doesn't exist in isolation. I'm sure there are marine environments off the coast that are their own depositional environments, which thousands to millions of years from now will wind up forming one stratum that can be traced laterally through environmental changes. And that's just one single example. The Sahara Desert is another depositional environment that's about 9 million square kilometers. And I don't know how to say it, so I'm going to say Pantanal wetlands? Sounds good to me, are a depositional environment that is about 140 to 195,000 square kilometers. Hell, even if we stick to the river delta example of a depositional environment that you yourself chose, the largest river delta in the world is the Ganges River Delta, which spans an area of 105,000 square kilometers. And all the rivers that feed into it are their own depositional environments, carrying sediments from glaciers at their sources and depositing them all along the riverbeds, with most ending up at the delta. And actually, that applies to all of these environments. None of them exists in a vacuum. And while there are plenty of places on the Earth where deposition is not happening, or at least not in the way that is conducive to the preservation of future rocks, the fact remains that we have exactly the same depositional environments on exactly the same scales as we observe in the geologic record. So, yeah, as Lyell observed, the present is indeed the key to the past.
we find these little fan-shaped deposits and really these river deltas forming. That's our biggest, most wide, extensive sedimentary bed that we can point to, our river deltas.
Actually, the river delta is one of the smaller environments that I just named, and I wasn't even trying to find bigger environments. It just so happens that bigger environments are super duper easy to find. Next, he goes through Steno's other principles: superposition, which is the idea that older layers are lowered down; initial horizontality, the idea that when rock layers form, they are initially horizontal, and if they are currently not horizontal, that's because of some event that happened later; and cross-cutting relationships, that is, if there is an intrusion into a layer, the layer itself is older than the intrusion, because an intrusion can't intrude into a layer that's not there. Amusingly, though, in another example of his lack of attention to detail, he calls the principle of superposition the principle of superimposition.
So the law of superimposition and the law of original horizontality.
It's all the more funny because he accidentally said it correctly, but then realized he had it written down, but didn't realize that it was written down wrong, and so he corrected himself to the incorrect name. Also, he skipped the cross-cutting relationships one. I'm not sure why. Probably just a simple lack of attention to detail again, rather than anything nefarious. Though certainly with this guy, nefarious is not off the table.
But simple demonstration can show that both of these laws are also not true on any kind of universal basis. These, you can see in this video, these particles of light and dark particles are forming distinct layers at the exact same time in violation of the law of superposition, but the layers are also not forming horizontally either.
Well, first and foremost, while I haven't really corrected you thus far because they are sometimes called laws, they are more frequently called principles, because they are not 100% universal. And aeolian deposition of sand dunes by wind is one situation in which a bed will have what is called cross-bedding. That is, the stratum itself will be horizontal, or rather originally horizontal, but there will be areas of deposition that occur at an angle to the main plane of the bedding. And since the rain in Spain stays mainly in the plain, I can't think of an end to that joke, but my partner loves My Fair Lady and wouldn't be happy with me if I didn't take that opportunity to at least attempt a relevant joke.
The rain in Spain stays mainly in the plain.
Anyway, the video he's showing looks like it would be roughly analogous to aeolian deposition, where the overall stratum would be horizontal, but the individual dunes would be at an angle with the stratum. But more important than the original horizontality thing, he's saying that all of these layers are forming at the same time. I beg to differ. The ones at the bottom very clearly form before the ones at the top. Here's a screenshot of the layers when he first showed them at timestamp 13 minutes and 44 seconds. And here it is at the end, after simulated deposition happened at timestamp 13 minutes and 55 seconds. Notice how earlier in time, the top layers were not there, and later in time, they are there. That means that they are younger. Now, in this example, they may only be younger by a matter of seconds, but the fact remains that they are, in fact, younger. So while there can sometimes be exceptions to Steno's principles in some cases, this ain't it.
Well, numerous physical actions can create strata rapidly. Any natural process that can suspend particles for even a brief period will cause them to form distinct layers. It doesn't take long periods of time. It doesn't take changes in depositional environments for different layers to form.
Yeah, I can agree that there are many stratiforming mechanisms that can and do act quickly. But that doesn't help your case, because all of these environments are found right in the middle of rock layers that creationists claim were laid down by Noah's flood, which you have actually demonstrated in this very video would have laid down one big conglomerate layer that was roughly sorted with a gradient, leaving the large grains on the bottom and the small grains at the top. But since that's not what the stratigraphic column looks like in any location that we know of, we can conclusively rule out such an event. As to the comment about it not requiring a change of environment, I can only guess at what you mean, but it seems that when you say environment, you're thinking more of climate and ecology rather than depositional environment. A river is itself a depositional environment, and if it terminates in a delta, then that delta is a different depositional environment from the rest of the river. So yeah, a river in isolation does not require a change in environment, but as you trace its deposition, the depositional environment will change as you go. Now, I'm going to go ahead and skip a bunch of his video. When I come back in, he's talking about the Tepete sandstone and claiming that most of it is turbidite, layers that are formed because of underwater landslides.
Well, a map of the Tepete sandstone deposit, that one we looked at the Grand Canyon, this is a map showing where those same deposits can be found over North America.
No, that is not a map of the Tapete Sandstone. That is a map of the Sauk megasequence, which can be found over most of North America. The Tapete Sandstone is a part of the Sauk megasequence, which is a stratigraphic sequence that indicates that most of North America was covered by a shallow, relatively calm sea for most of the deposition of that sequence.
If that is the result of an underwater landslide, I mean, what else could cause a formation like this other than a continental-wide flood catastrophe?
A continental-wide shallow sea that transgressed during the Cambrian and regressed during the Ordovician, which notably is before creationists claimed the floodwaters would have subsided. Throughout the whole Sauk sequence, there are a plethora of depositional environments in evidence. Yes, some turbidite exists, but there are so many environments that are represented in this sequence that to generalize any depositional environment and say that it applies to the whole sequence is just laughable.
Well, some geologists suggest that 50% of the world's sedimentary rocks might in fact be turbidites.
I'm going to need a source for that claim that's a bit less nebulous than some geologists. I'm having trouble pinning down an exact number, but I am seeing that turbidity currents are indeed among the most common types of events that cause deposition that we see in the stratigraphic column. So maybe it is as high as 50%? I don't know. I need more specificity than some geologists in order to figure this out. Anywho, it doesn't really matter all that much because this fact doesn't actually support a worldwide flood. Because there are instances where turbidity currents happen in close proximity, but we can tell that they did not happen at the same time because of how the turbidity currents would have interacted had they actually happened together. And this is actually where I'll leave it for today. He does go into an old experiment that supposedly shows that the principle of superposition doesn't always hold true by showing that different layers can form simultaneously. And the point he tries to make with this is that the different layers with different types of rock could form at the same time in the same depositional environment, but unfortunately for him, it basically just amounts to another version of the shaken up beaker with different types of particles suspended in water experiment, but with an added current. It completely ignores the fact that we can tell from examining the rocks what type of environment they formed in, and it's also, once again, a counter to his earlier point. He was trying to emphasize just how much deposition was caused by turbidity currents in an attempt to say that all of the turbidity currents happened because of the flood. But in order to determine that sediment was laid down by turbidity currents, you rely on the same methodology that tells us that a lot of these turbidity currents were separated by long periods of time, which had very gentle depositional environments. And so ends today's installment of the Self-Debunking Creationist. Today's comment of the day comes to us from Tiki Tiki Tango 5634, who says, "Which worldview has fewer unanswered questions? In my opinion, a wrong answer is worse than an unanswered question." Absolutely. Just because you can answer any question with "God did it," does not mean you have a better worldview because it answers more questions. I could just as easily answer the same questions with an all-powerful sentient cloud of fart gas did it, and that answer would be just as valid as "God did it." That is to say, it would be a useless answer. Thanks for watching. I'll be back next Friday with more, but if you need to get your Rhino fix in before then, I live stream with Cirrus every Wednesday at 8:30 Eastern on my other channel, The Watering Hole, and I stream with my partner every Tuesday at 1 p.m. Eastern here.
Don't forget to go to surfshark.deal/rhino to get 3 extra months for free.
Thanks to Tim Robertson for being my Patreon and sponsorships manager, and special thanks as always to my patrons, who are the evidence that I'll bring up that debunks the last thing that I said that is my channel. If you'd like it if I prove myself wrong in my own videos, you can join us on Patreon for as little as $1 per week over at patreon.com/ViceRhino, or by supporting the channel in one of the other methods that can be found at links.vicerhino.com, which is also where you'll find links to my other projects. If for whatever reason you want to send me stuff, my P.O. Box address is in the description. See you next time!
And since the rain in Spain mainly... And since the rain in Spain...
Didn't I say that?
No, Eliza, you didn't say that. You didn't even say that.